Welcome to The Explainer. Today, we're going to deconstruct the hidden systems behind the maps we use every single day. If you think about it, we interact with maps constantly, right? Whether we're navigating a new city on our phones or just checking a global weather forecast. But today, we're not just looking at maps as helpful little tools. We're going to examine them as complex, constructed documents.
So here's a question. Are maps just objective mirrors of reality? We tend to think of them as perfectly neutral reflections of the world, a one-to-one copy of reality. But the truth is, they are constructed languages, and they're incredibly powerful social tools. A map is less like a photograph, and, well, actually it's way more like a highly edited essay. Every single map you've ever looked at is a result of thousands of conscious decisions about what to include, what to emphasize, and maybe most importantly, what to leave out.
To truly understand how maps work beneath the surface, we have to look at cartosemiotics. This is the academic study of map language and how it uses signs to convey geographic info. In cartosemiotics, a map is basically viewed as a material text. It contains a whole universe of concepts. Think lakes, bridges, populations, and it pairs them with expression material. That's the actual shapes and colors we see on the page or the screen.
Now, there is a totally fundamental difference between absolute location and symbolic meaning in cartography, and this is absolutely crucial to grasp. The exact mathematical position of a symbol represents its absolute location. That's tied to real-world geographical coordinates through strict point-to-point matching. But the symbols themselves, say using a square for a gold mine, a circle for copper, and a triangle for iron, that is symbolic meaning. The cartographer deliberately chooses these arbitrary shapes to differentiate the mines without implying one is somehow better than the other. It's this brilliant merger of precise mathematical space with abstract human language.
To build this language, mapmakers communicate by drawing from three types of signs. These were defined by the founder of modern semiotics, Charles Sanders Peirce. First up, we have iconic signs. These actually look like the real objects. Think of a tiny airplane icon representing an airport, or drawing little trees for a forest. Second, we have index signs. These indicate relationships. For instance, a set of really closely packed contour lines tells you that a slope is incredibly steep. And finally, we have symbolic signs. These rely on learned conventions and have zero physical resemblance to the actual object. A classic example is using the color blue to represent cold temperatures and red for warmth, because obviously temperature doesn't actually look like a color out in the real world.
Section 1. Critical cartography, the hidden power of maps. Let's get into it. Critical cartography reveals that maps reflect hidden powers, and they usually favor a society's dominant group. The famous map projection debate illustrates this perfectly. Way back in 1569, Gerardus Mercator introduced a map projection that was flawlessly designed to preserve compass bearings for navigation. A real game changer. But to achieve that, it drastically distorts size as you move away from the equator. The result? It makes Greenland appear larger than the vastly bigger continent of Africa. To put that in perspective, in reality, Africa is about 14 times larger than Greenland. Contrast that with the Gall-Peters projection. This one preserves actual land area, but it distorts the shapes of those land masses. Critical cartographers point out that because size is so often associated with power and importance, the Mercator projection's mathematical choices inadvertently influenced our worldview. It visually inflated the Northern Hemisphere and perpetuated concepts like Eurocentrism. It just goes to show that even the absolute mathematical equations used to map a sphere onto a flat surface carry profound social weight. Because dominant cultures and colonial powers have historically controlled cartographic representation, often naming and claiming territories long before they were even effectively occupied, alternative groups use a practice called countermapping. This is a fascinating way for them to reclaim their territories, assert their rights, and actively challenge dominant historical narratives using the exact same tools of cartography.
Imagine a community of over 250,000 people just missing from the map. For a really long time, Kibera, Kenya was essentially just a giant blank space on Google Maps. No way, right? But in 2008, a countermapping project organized entirely by locals changed everything. By gathering their own data, they documented 5,000 structures, public toilets, and water supplies. This incredible grassroots mapping effort gave visibility and data-backed existence to a massive population, estimated between 235,000 and 270,000 people, who were previously completely invisible to the digital world.
Similarly, critical cartographers study how maps are utilized to represent contested histories. For example, Palestinian refugees have used tools like Google Earth to engage in countermapping, specifically mapping out original Palestinian villages that were destroyed in the aftermath of 1948. Other initiatives involve architecture students actually designing reconstructions of these villages. It's a clear demonstration of how cartography captures deeply contested geopolitical perspectives, serving as an academic medium for both historical memory and territorial claims.
Section 2. The Digital Mapping Revolution. The way we create, control, and interact with these symbolic documents fundamentally changed when we left the printing presses behind for a dynamic, paperless era. Computer cartography evolved from Waldo Tobler's early map-in, map-out, or MIMO system back in 1959. That was the first time maps could be digitized and altered. We hit a massive milestone in the mid-1990s when, for the first time, more maps were created and distributed via computers than paper. Then, we zoomed straight into the 2000s expansion of mobile computing and the GPS revolution, leading us directly to today's frontier, generative AI.
Let's look closely at the Global Positioning System, or GPS. It relies entirely on absolute location. Modern navigation collects data from orbiting satellites to calculate your exact three-dimensional coordinates. But pure coordinates aren't exactly helpful to a human driver, right? So the software immediately translates that absolute data into a symbolic, real-time visual route right there on your screen. It is a completely seamless integration of absolute geodesic data and symbolic digital interfaces.
Section 3. The Future. AI in Modern Cartography.
We are now entering the era of generative artificial intelligence, where algorithms aren't just calculating your position anymore, they are conceptualizing the maps themselves. Technologies like large language models, diffusion-based image generators, and Gen AI agents are totally pushing the boundaries of cartographic theory and practice. AI has this exceptional ability to encode extensive knowledge, adapt to different contexts, and integrate multimodal information, which is completely transforming the map-making workflow from the ground up.
In mapmaking, AI is stepping in to automate incredibly complex cartographic design decisions. It can help brainstorm the map's entire purpose, prepare the messy data, and handle the symbolization process. It essentially translates abstract data into visual variables like shape, size, and color. This allows for rapid, highly personalized map creation that still balances beautiful aesthetics with hard, factual information.
And it certainly doesn't stop at creation. On the map use side, Gemini introduces some incredible new opportunities. It can actually aid users in reading maps by recognizing complex symbols, interpreting spatial patterns, and performing really deep analysis. It helps us derive meaningful geographic insights across all kinds of data inputs, acting almost like your own highly trained geographic assistant.
Now, the crucial thing to remember here is that while this technology is incredibly powerful, it's definitely not perfect. AI models still suffer from hallucinations and biases. They struggle with tasks that require absolute geodesic precision and deep reliability. There's also this fascinating concept called the cartographic paradox. It turns out the more a map strives for exhaustive, perfect, absolute accuracy, the less navigable it becomes for an ordinary human. To actually be helpful to us, a map needs a certain level of abstraction and symbolism.
Ultimately, whether a map is drawn by hand by a 16th century explorer, beamed down to your car's dashboard from a network of satellites, or generated in seconds by a multimodal AI agent, the words of critical cartographer John Brian Harley remain deeply true. Maps are never value-free images. They are always a blend of absolute location and human interpretation.
So here's what I want you to take away from this. The next time you pull up a map on your device to find the quickest route or to try and understand a global event, take just 1 second to look past the illusion of neutrality. Ask yourself, what choices, what symbols, and what invisible powers helped build that specific view of the world? Thanks for joining me on this explainer. Keep learning, and I'll catch you in the next one.